Good morning, class. So today we're looking at simultaneous equations. Simultaneous equations are two equations. Okay, you get simultaneous equation of 3 or 4 or so on. So for high school, for high school syllabus, we are looking at simultaneous equations of two equations. We're reading from page 83 of the Study and Master. Here we are told that simultaneous equations, the simultaneous solutions of x and y in two equations means we find the x and y, so that coordinate which satisfy both equations. It is a point where the graph of the two equations cut one another. Okay? So when you see two graphs intersecting each other, we can do that calculation, or we can work out that point by using simultaneous equations. Okay. So important to note, the first equation has one unknown, example x. We name that equation 1. And the second equation has two unknowns, example x and y. Method: use the first equation and make the variable x or y the subject of the formula. Number 2, now substitute x or y value into the second equation. We're going to go straight into example 1. At this point you have written down all of this. You all finished, no?
Yes, sir.
So let's go. In example 1, I want you guys to write that down. Example 1, to solve for x and y if x plus 2 is equal to 0 and x minus y is equal to 3. Okay, so here we got two equations, not so. So we got equation x plus 2 equals 0, let's call this equation 1. And we got x minus y is equal to 3, and we're going to call this equation 2. So do that quickly. Alright, so looking at equation 1. How many unknowns do I have here? 1. In equation 2 you have 2 unknowns. Not so. My girl, what is going on at the back? Leave the phone, my girl, man. You're not even supposed to be charging your phone here. So I give you that leeway. Now when I'm teaching here, you're busy with the phone. You think it's free? Okay, so equation 1 has 1 unknown, equation 2 has 2 unknowns. Okay, so we choose the equation that has 1 unknown, and we can solve that equation. So if we look at from equation 1, what can we see? We can solve for x, not so how? By taking that 2 over the equal sign. So that becomes x is equal to 0 minus 2, which is negative 2. You all see that, people? So now we have the x value. We now know what x is. So what do we do with that? We substitute this into second equation. So now we're going to substitute. X is equal to minus 2 into equation 2. Now you guys do the substitution for me too. Right, so what do we have now? Now we have x is now minus 2, not so? So negative 2 minus y is equal to? Is equal to 3. Why negative 3? Okay. So what do I do now in pursuit of calculating y now? Take a negative 2 over the equal sign. So what does this now become? Negative y is equal to 3 plus 2. Not so? Remember, I'm not taking the y anyway. I'm keeping it there. So the y must remain negative. So we have negative y is equal to 5. I divide by negative 1 both sides. Therefore y is equal to? Alright, so let's read again what did they tell us? They told us the method, use the first equation and make x or y the subject of the formula. We made x the subject of the formula. And then the second equation, now substitute the value of x or y into the second equation. And that's what we did. Alright, you guys okay with that? Any confusion? No? Now I'm looking at example 2. Example 2. On page, the next page. Which page is that on? Sorry? 33. 83. So who can tell us where do we start here? Sorry? We work equation 1 and equation 2. We label the equations. Not so? So we make 2x minus 5y equals 4. And we have 2y minus 4 is equal to 2. This is equation 1. This is equation 2. Write that down. So which equation do you think we're going to work with first and why? Second equation. Yes, why? There's only one unknown. But I make a note there for those of you who didn't know. We're going to work with equation 2 first because it only has one unknown, namely y. Can you see that? Alright, so from equation 1, what can I say from equation 1? I'm going to take the 4 over, not so? Alright, now you solve for y equal. Are you guys finished? Yes, okay. You get 1 over, you get 2y equals 2 plus 4. What's 2 plus 4? So 2y is equal to 6. Now what? Divide by 2 both sides. Therefore y is equal to? You all agree with that?
Yes, sir.
Any confusion? So what do I do now? Substitute y, which is y is equal to 3, into equation 1. Okay, y. So we want to solve for x now, not so? You want to substitute that. Do this. Okay, I want to show you something else also from the previous question. Okay, so what do we have? We have, just put this down a bit. We have 2x minus 5 into 3. Remember y is now 3 equals 4. You all agree with that?
Yes, sir.
So what do I do now? Get rid of that back bit, not so. So it's 2x minus 15 equals 4. Now what? Negative 15 over becomes 2x is equal to 4 plus 15. What's 4 plus 15? 19. Divided by 2. X equal to? Okay. Now this coming back to this equation here, this is a bit easier to work with. If I'm going to draw this graph, okay, and if the question says solve for x and y, we don't have to draw this graph, okay? I'm just going to show you something. If I must draw this graph, okay, your x-intercept at y equal to 0, so x is 3, y-intercept at x equal to 0, x equal to 3. Can you see that? So what I'm going to do is I'm going to draw this here, these lines in, to show you. I want to illustrate to you something quickly. Okay. So if I must draw this graph, okay, then the graph is going to go through 3 and 3, not so?
Yes.
We will draw, this is what the graph is going to look like. That's y and that's your x, no? This is the graph. X minus y is equal to 3. Now if I must draw the other graph, which is this x plus 2, that's the same as x is equal to minus 2 graph. Not so? And I draw that graph. Okay, this minus 1, minus 2. I'll take this up a bit. extend that there. Can you see? Then this graph of x equal to minus 2 is this graph here. Not so? What do you notice? What's the coordinate of that point? This is 1, 3, 4, 5. What's the coordinate of this point?